Good morning students, this is Latif sir. In this video, today I will discuss about chemical properties or chemical reaction of alcohols and phenol. Chemical reactions of alcohols and phenols. So first see reaction of alcohols and phenols involving the cleavage of OH bond present in the alcohol. First type of reaction or chemical properties is acidity of alcohol and phenol. Acidity of alcohols and phenols. You know, phenols and alcohols are to some extent acidic in nature and especially aromatic alcohol, that is phenols, are more acidic than aliphatic alcohols. And the acidic property of alcohols and phenol can be shown by reaction with sodium. When alcohol and phenols react with sodium, hydrogen gas evolves. Okay, and this reaction shows the acidic nature of alcohol and phenols. Okay, when alcohols and phenols react with sodium, you will get sodium alkoxide. When alcohol reacts with sodium, you will get sodium alkoxide, or when phenol reacts with sodium Na, you will get sodium phenoxide and hydrogen gas. Okay, and liberation of hydrogen gas shows the acidic nature of alcohols and phenols. But you have to remember that alcohols and phenols are weaker acid than acid. Alcohols and phenols are weaker acid than than carboxylic acid. Okay, and acidity of different alcohol decreases from primary alcohol to secondary alcohol to tertiary alcohol. That means primary alcohol is more acidic than secondary alcohol than tertiary alcohol. This is because the inductive effect of this is due to inductive effect, plus I effect. This is due to plus I, it is plus I. This is due to plus I effect of the alkyl group. Okay, alkyl group has a plus I inductive effect, and due to plus I effect of alkyl group, acidity of different alcohol decreases. As the number of alkyl group, number of electron with donating group increases with the carbon atom, then acidity of the alcohol decrease. Okay, especially you have to remember the acidic nature of different alcohols, different aromatic alcohols. Okay, and like acidic nature of orthokesol, less than parakesol, less than metakesol, less than phenol, less than orthonitrophenol, less than 2,4,6 trinitrophenol, that is picric acid. So if you have to remember, if electron withdrawing group is present in the benzene ring of phenol, if electron withdrawing group is present in the benzene ring of the phenol, then acidic nature of phenol will increase. And if electron donating group is present in the benzene ring, then acidic nature of phenol will decrease. Okay, if G is electron withdrawing group like NO2 group, like nitro group, then acidic nature of phenol will increase. And if electron donating group like methyl group, then acidic nature of phenol will decrease. Okay, so acidic nature of phenol, you have to remember different phenols, substituted phenols. Now second type of reaction is esterification reaction. Esterification reaction means reaction of alcohols with acid, carboxylic acid. When one alcohol reacts with one carboxylic acid molecule, one ROH reacts with RCOOH, one water molecule will remove. Okay, and alcohol will combine with acid group, alcohol group OH group will combine with COOH group, and it will produce ester, RCOOR. Okay, this is the general formula of ester. When alcohols react with acid, in presence of acid catalyst, sulfuric acid catalyst, H2SO4 catalyst, okay, you will get ester and water. Okay, so not alcohol reacts with when alcohol reacts with carboxylic acid, it will produce ester. Similarly, when alcohol reacts with acetic anhydride or acid chloride, it will also produce ester. Okay, so when alcohol reacts with carboxylic acid, mainly carboxylic acid, and in some cases when alcohol reacts with acetic anhydride, RCOO whole twice RCO whole twice O, this is acid anhydride. This is the general formula of acid anhydride. Okay, when alcohol react with carboxylic acid or acid anhydride in presence of H plus, in presence of H2SO4 catalyst, then you will get ester and and one more product. Okay, similarly when alcohol reacts with acid chloride in presence of pyridine, you will get ester and HCl. Okay, one example of esterification reaction is given here. When salicylic acid, it is an aromatic alcohol because OH group is present. In salicylic acid, both OH group and acid group is present. When salicylic acid reacts with acetic anhydride, this is CH3CO whole twice O, acetic anhydride in presence of concentrated H2SO4, salicylic acid combined with acetic anhydride. This is the reaction between OH group of phenol salicylic acid and CH3CO group of acetic anhydride to produce ester. The OH group will be converted into OCOCH3 group. You have to remember the changes. Okay, and the salicylic acid will be converted into acetyl salicylic acid, or it is also called aspirin. Acetyl salicylic acid, also called aspirin. Okay, very important compound. When salicylic acid combined with acetic anhydride, you will get aspirin and acetic acid. Okay, now see reaction of alcohol involving CO bond of alcohols. CO bonds of alcohols. So first type of reaction is reaction with halogen. Reaction with halogen. When alcohol reacts with hydrogen halide like HCl, HBr, HI, the CO bond will break and the OH group will be substituted by halogen atom RX. Okay, alcohol reaction of alcohol involving CO bonds or RO bond. Okay, so when alcohol reacts with hydrogen acid, halogen acid like HCl, HBr, HI, the OH group of alcohol will be substituted by halogen atom. Okay, and here HI is more reactive than HBr than HCl, and this for a given halogen, the order of reactivity of alcohols is tertiary alcohol is more reactive than secondary than primary. For a given halogen acid, the reactivity of alcohols is tertiary alcohol is more than secondary alcohol is more than primary alcohols. Okay, and you can differentiate different type of alcohol using Lucas test. Okay, and you have to remember what is Lucas reagent. Anhydrous ZnCl2 and concentrated HCl is known as Lucas reagent. This is known as Lucas reagent. Using Lucas reagent, you can differentiate different type of alcohols: primary, secondary, and tertiary alcohols. Primary alcohols, that is the general formula of primary alcohol, you know that RCH2OH. RCH2OH is general formula of primary alcohol. Primary alcohol reacts with Lucas reagent. Primary alcohol do not react with Lucas reagent, and no white turbidity is formed at room temperature for primary alcohol. But when secondary alcohol reacts with Lucas reagent, secondary alcohol means R2CHOH. R2CHOH, when reacts with Lucas reagent, that is anhydrous ZnCl2 and concentrated HCl, a white turbidity appears within 5 minutes due to formation of this product R2CHCl, substitution product. And tertiary alcohol reacts very rapidly. Okay, so when tertiary alcohol reacts with Lucas reagent, it will produce R3CCl, R3COH. When reacts with Lucas reagent, it will produce R3CCl, and a white turbidity appears immediately. So using Lucas reagent, it is given in the syllabus. Using Lucas reagent, you can differentiate primary alcohol, secondary alcohol, and tertiary alcohol. Tertiary alcohol reacts very fast with Lucas reagent, then secondary alcohol and primary alcohol do not react with Lucas reagent easily. Okay, now see reaction of alcohol and phenol with phosphorus halide like PCl5, PBr3, PI3. Same reactions, OH group of alcohol will be substituted by halogen. OH group of alcohol will be substituted by halogen. Okay, for example, ROH, it is alcohol. When reacts with PCl5, the OH group of alcohol will be substituted by halogen. So ROH plus PCl5, it will be RCl plus POCl3. So similarly, when ROH reacts with PBr3, the OH group of alcohol will be substituted by bromine atom. When alcohols react with Pi3, the OH group of alcohol will be substituted by iodine. So this is a substitution reaction mainly. Okay, and reaction with thionyl chloride. Thionyl chloride is SOCl2. When same reaction, substitution reaction, when alcohols, any alcohols, in general, in general ROH plus SOCl2. Lucas reagent, thionyl chloride means SOCl2. When alcohol reacts with SOCl2, the OH group of alcohol will be substituted by Cl atom. Okay. Now see dehydration of alcohols. Dehydration means removal of water from alcohols. Okay, when alcohol is treated with concentrated sulfuric acid at 443 Kelvin, one water molecule will be removed from alcohol. The alcohol will be converted into alkene. Okay, so mechanism is not important. Just remember, if you add concentrated sulfuric acid to alcohol, if you heat alcohol with concentrated sulfuric acid, one water molecule will be removed, one H2 molecule will be removed from alcohol, and the alcohol will be converted into alkenes. Okay. Mechanism is also given here. And next, oxidation of alcohols. Oxidation, different type of oxidizing agent are given here: alkaline KMnO4 or acidified potassium dichromate. Okay, so first you have to see the general scheme of oxidation. A primary alcohol on oxidation, it gives aldehyde, and on further oxidation, within square bracket O, which represent oxidation. Okay, so primary alcohol when oxidized, it first give aldehyde, and on further oxidation it gives carboxylic acid. Similarly, secondary alcohol CHOHR, that is CH3 CHOH CH3, secondary alcohol, it is secondary alcohol. On oxidation first give ketone, the CHOH group converted into C double bond O group. Okay, and ketone on further oxidation, it gives acid, carbon dioxide and water. And tertiary alcohol, that is R3COH, that is CH3 whole thrice COH. On oxidation it gives ketone, carbon dioxide and water. Okay, and the initially produced ketone, on further oxidation it gives acid, carbon dioxide and water. So these are general oxidation methods. You can use any one oxidizing agent here given: acidified potassium dichromate or alkaline KMnO4. Okay, and one more important reagent is pyridinium chlorochromate. Pyridinium chlorochromate. Pyridinium chlorochromate. It is used to oxidize primary alcohol to an aldehyde. Okay, if you want to oxidize primary alcohol to aldehyde only, that is limited oxidation, then you have to use PCC. PCC or pyridinium chlorochromate. This reagent is only used when if you oxidize primary alcohol group to aldehyde group, not to acid group. Okay, this is limited oxidation of alcohol. Primary alcohol on treatment with PCC, it converted into aldehyde group, not to acid group. One more oxidation is given, or it is also called dehydrogenation. Reaction of alcohol with water. Same reaction, oxidation reaction. uh, if you heat alcohol with copper at 300 degrees Celsius, if you treat alcohol with copper at 300 degrees Celsius, one hydrogen molecule will be removed from alcohol, and the alcohol will be oxidized to aldehyde. Primary alcohol will be oxidized to aldehyde, and secondary alcohol, that is R2CH CHOH, CHOH group will be oxidized to ketone group RCOR, RC double bond OR plus hydrogen. And tertiary alcohol on heating with copper at 300 degrees Celsius, tertiary alcohol mainly give alkene. Okay, so these are mainly oxidation reaction. There are many oxidizing agents are given here, you can see, like acidified potassium dichromate, alkaline KMnO4. Okay, a primary alcohol generally gives on oxidation aldehyde, and on further oxidation give acid. Secondary alcohol on oxidation gives ketone, on further oxidation give acid, carbon dioxide and water. And tertiary alcohol on oxidation gives ketone and carbon dioxide and water, and ketone on further oxidation gives acid, uh, carbon dioxide and water. Okay, and now see distinction between 1 degree, 2 degree and 3 degree alcohol. Distinction between 1 degree, 2 degree and 3 degree alcohol, you can distinguish by Lucas test. I have already told that Lucas Victor Meyer test is not given in the syllabus, it is not required. Victor Meyer test is not required, but you have to read the Lucas test to distinguish 1 degree, 2 degree and tertiary 1 degree, 2 degree and 3 degree alcohols. Now see reaction of aromatic alcohol or phenols. Reaction of aromatic alcohols, mainly electrophilic substitution reaction of phenols. So first reaction is halogenation reaction. Remember that OH is ortho-para directing group. Okay, the electrophile will enter at the ortho and para position. Ortho position, this one is ortho position, and this is meta and this is para. This is also meta and this is also ortho. So phenol, in phenol OH group is present, and OH, remember that OH is ortho-para directing group. On electrophilic substitution reaction of phenol, the electrophile will enter at the ortho and para position. Okay, so when phenol is treated with bromine in bromine water, when phenol is treated with bromine water, you will get 2,4,6 tribromophenol. Okay, so when phenol is treated with bromine water, you will get 2,4,6 tribromophenol, a white precipitate, white PPT of 2,4,6 tribromophenol. Important reaction. Okay, similarly, if bromine is treated with phenol in presence of carbon disulfide, not in presence of water, it is also bromine in carbon disulfide, then you will get only 2 bromophenol or 4 bromophenol, that is orthobromophenol and parabromophenol. Not, you will not get 2,4,6 tribromophenol if you react bromine in carbon disulfide with phenol. Okay, but bromine, when phenol is treated with bromine water, then you will get 2,4,6 tribromophenol. Very important reaction, you have to remember the reaction condition in both cases. Now see sulfonation, that means SO3H group will enter into the benzene ring when phenol is treated with concentrated sulfuric acid. When phenol is treated with concentrated sulfuric acid, see concentrated H2SO4, one SO3H group will enter at the ortho and para position of phenol, because phenol, OH group of phenol is ortho-para directing group. So you will get ortho-hydroxy benzene sulfonic acid and para-hydroxy benzene sulfonic acid when phenol is treated with concentrated sulfuric acid. Next reaction is nitration, that is NO2 group will enter into the benzene ring. When phenol is treated with concentrated nitric acid and concentrated sulfuric acid, this is nitrating mixture. Okay, when phenol is treated with concentrated nitric acid and concentrated sulfuric acid, you will get 2,4,6 trinitrophenol. It is also called picric acid. Trinitrophenol, it is also called picric acid. When phenol is treated with 2,4,6 phenol is treated with concentrated nitric acid and concentrated sulfuric acid, you will get 2,4,6 trinitrophenol. You have to practice all this reaction, very important reaction, electrophilic reactions of phenols. Okay, next reaction of phenol with dilute. If you use dilute nitric acid at room temperature, then you will get only orthonitrophenol and paranitrophenol. Okay, then you will not get 2,4,6 trinitrophenol. If you react phenol with concentrated nitric acid and concentrated sulfuric acid, then you will get 2,4,6 trinitrophenol. Okay, next reaction, reaction of this reaction I have told, reaction of bromine with water, reaction of phenol with bromine in presence of carbon disulfide. And next reaction is Reimer-Tiemann reaction, very important reaction of alcohols, phenols. Reimer-Tiemann reaction, in Reimer-Tiemann reaction you can produce, using this reaction you can produce phenol to salicylaldehyde. Salicylaldehyde means OH group and CHO group. You can enter one CHO group in the benzene ring of phenol. using Reimer-Tiemann reaction. So in Reimer-Tiemann reaction, you have to remember what are the reagents. In first step, chloroform CHCl3 and aqueous NaOH, and almost 60 degrees Celsius temperature is required. So when phenol is treated with chloroform in aqueous NaOH medium, chloroform CHCl3, phenol is chloroform. First, this type of compound intermediate will form, and this intermediate on hydrolysis in second step, on hydrolysis with HCl, you will get salicylaldehyde, main product, chief product. Okay, that is one CHO group will enter at the ortho position of OH. Okay, and in Reimer-Tiemann reaction, the intermediate is this CCl2. Okay, dichlorocarbon, it is also called dichlorocarbon. So Reimer-Tiemann, using Reimer-Tiemann reaction, you can produce phenol to benzyl salicylaldehyde. Okay, if you want to introduce one CHO group at the ortho position of phenol, then you have to do this reaction. One more reaction is given, it is also called Reimer-Tiemann. Instead of chloroform, if you use carbon tetrachloride CCl4, instead of chloroform CHCl3, if you use carbon tetrachloride CCl4 in aqueous NaOH medium, then you will get salicylic acid as the major product, that is orthohydroxybenzoic acid as the major product, and as minor product para-hydroxybenzoic acid. Okay, so if I generalize this reaction, in Reimer-Tiemann reaction, if you use carbon tetrachloride, if you use chloroform in aqueous NaOH, and in second step, if you hydrolyze the reaction by acid, then you will get salicylaldehyde. And if you react phenol with carbon tetrachloride in first step, in carbon tetrachloride in aqueous NaOH medium, and in second step, if you use dilute HCl or H plus, you will get salicylic acid as the major product. Okay, one more important reaction is Kolbe reaction. Kolbe's reaction, similar type reaction. In Kolbe's reaction, first phenol is treated with NaOH to give sodium phenoxide. Okay, sodium phenoxide, and in second step, sodium phenoxide is treated with carbon dioxide in presence of H plus, carbon dioxide in presence of acid. Then finally you will get salicylic acid, this product. Okay, after when sodium phenoxide is treated with carbon dioxide and H plus, similar product you will get, that is salicylic acid you will get. So in Kolbe's reaction, first you have to use NaOH, and second step you have to react the sodium phenoxide with carbon dioxide and H plus. Okay, and three more esterification reaction is given. Reaction of salicylic acid. First reaction with phenol, there's C6H5OH, you will get this phenyl salicylate, it is also called salol. If you react this salicylic acid with CH3COCl in presence of acetic anhydride, you will get acetyl salicylate. See the changes. When salicylic acid react with methanol, then you will get methyl salicylate, or it is also called iodex, or it is also known as oil of wintergreen. In presence of acid, you have to remember, in presence of acid catalyst H plus. Okay, so very important reaction, these reactions. Reaction of salicylic acid with phenol, reaction of salicylic acid with acetyl chloride in presence of acetic anhydride, reaction of salicylic acid with methanol. Okay, and last reaction is reaction of phenol with zinc dust. Very simple reaction. When phenol is treated with zinc dust, phenol is converted into benzene. And oxidation of phenol on oxidation with sodium dichromate Na2Cr2O7. Okay, have written the reagents Na2Cr2O7 sodium dichromate in H2SO4, Na2Cr2O7 in H2SO4. When phenol is oxidized by Na2Cr2O7 in presence of H2SO4, you will get para-benzoquinone. It is para-benzoquinone. Okay, and Fry's rearrangement is not required, not given in the syllabus. Thank you, students.